We'll go back to the deep dive. This time we're going from zero to, well, not exactly hero, but definitely from training an LLM to actually using it.
Yeah, deployment, it's a whole different world from that nice, comfy training environment.
Right. Like we've got this powerful engine, but now we need to build the entire car around it. And we've got some great research here to guide us, everything from how to set up the infrastructure to choosing the right tools for the job.
It's a lot more than just hitting deploy and calling it a day.
Definitely. So let's start with the absolute basics. How do we even get an LLM set up to handle, let's say, requests from a chatbot or something like a text summarization tool? What's the architecture there?
At its core, it's the classic client-server model. So your chatbot, for example, that would be the client sending requests to a server where the LLM's running.
Okay.
And the way they talk to each other is through an API. Think of it like a common language they both understand. It defines how the requests are formatted and how the responses are sent back.
So the API is like the rulebook, making sure the client's request is something the LLM can actually work with.
Exactly.
But running these LLMs, especially at scale, that's got to be a beast, right? Millions of dukers potentially hitting it with requests. How do you manage all that complexity and keep things running smoothly?
That's where specialized serving frameworks come in. These things are like a Swiss Army knife for deployment, and they handle a bunch of critical tasks like loading the model, managing the incoming requests, and even scaling out to handle huge numbers of users.
So it's not just about having a powerful LLM, it's also about having the right tools to support it.
Exactly.
Can you give us some examples of these serving frameworks? And like, what are the key differences between them?
Sure, yeah. Some of the popular ones out there, you've got Triton Inference Server, that's from NVIDIA. It's really flexible and supports multiple deep learning frameworks, which is nice.
Okay.
Then there's TensorFlow Serving from Google. As you can imagine, it's tightly integrated with the TensorFlow ecosystem, really shines in those distributed deployments.
Makes sense.
And we can't forget about TorqueServe, developed by PyTorch and AWS. It's known for being user-friendly and very scalable.
So it sounds like there are a lot of options. Choosing the right one probably depends on your specific needs, right? Like the LLM you're deploying and the environment you're deploying it in. Are there any other factors that come into play when choosing a framework?
Oh, absolutely. Performance is a big one, obviously. You need to consider how fast framework can process requests and how efficiently it utilizes the available hardware.
Right.
Support for different hardware platforms is key too. Some frameworks are more optimized for specific hardware like GPUs or TPUs.
Gotcha.
And don't underestimate the importance of community support and good documentation. A strong community can be a lifesaver when you run into problems or need guidance, and good documentation makes it much easier to get started and troubleshoot issues.
That's good advice for really any software you're working with.
Absolutely. Now, speaking of performance, there's another crucial aspect we need to address, especially when working with those massive language models, and that is model parallelism.
Ah, yes. Model parallelism. That came up a lot in our research. Can you break that down for us? What exactly does it mean in the context of deploying LLMs?
Sure. So when you're dealing with these LLMs, some of them are just enormous, right? Too big to fit on a single device. So you need to find ways to split them up, distribute them across multiple GPUs or TPUs.
Divide and conquer, essentially.
Exactly.
Make it manageable.
Now, one common approach is tensor parallelism. That's where you divide the model's parameters, those massive matrices of numbers, and distribute them across the different devices.
Okay, so each device is handling a slice of the model, making the computation much faster. Are there other ways to parallelize the workload?
Yeah, there's also pipeline parallelism. Think of it like an assembly line, right? Different devices handle different stages of the computation, so one device might handle the initial embedding layer, another the attention mechanism, and so on.
So the output of one stage becomes the input for the next stage, just like products moving down an assembly line. But doesn't that create potential bottlenecks? What if one stage takes longer than the others?
You got it. That's a critical point. When you have one stage that's slower than the others, you get what's called a pipeline bubble. It's like a slowdown on the assembly line holding everything up.
Right.
That's why load balancing is so important. You want to make sure each stage has a comparable workload to avoid those bottlenecks and keep things flowing smoothly.
So optimizing for these parallel processing techniques is key to maximizing performance. Makes sense. But even with all this parallel processing, those massive models still require a lot of computational resources, don't they? Are there ways to make them more efficient, to slim them down a bit without sacrificing accuracy?
There absolutely are, and that's where quantization comes in. It's all about using more efficient numerical representations for the model's weights and activations. Typically, we use 32-bit floating point numbers, but with quantization, we can switch to lower precision representations, like 8-bit imagers, without losing too much accuracy.
So it's like using a compressed file format, right? Sacrificing a bit of fidelity to reduce the file size significantly. What are some of the approaches to quantization?
The simplest method is post-training quantization. You take a trained model and quantize it afterward. But honestly, this can sometimes lead to a noticeable drop in accuracy.
Right.
A more sophisticated approach is quantization-aware training. This is where you actually train the model from the start to be efficient with those lower precision representations.
Oh, interesting. So it's like training your assembly line workers to be efficient with limited resources right from the beginning. That makes a lot of sense.
Yeah.
But hold on, before we get too deep into these optimization techniques, let's talk about where we're actually running these LAMs. Because I'm guessing it's not just on a single server in someone's basement.
You're absolutely right. Choosing where to deploy your LLM is a big decision with a lot of implications for scalability, cost, security, the whole nine yards. The main options you have are cloud platforms, on-premise deployments, and then there's the increasingly popular edge deployment.
All right, let's break those down one by one. Cloud platforms, those seem to be the go-to for a lot of applications these days. What makes them so appealing for LLM deployment?
Well, scalability is a huge factor. Cloud providers like AWS, GCP, Azure, they have these massive data centers designed to handle huge fluctuations in demand. If you need more computing power, you can just spin up more virtual machines or specialized hardware like GPUs.
So you don't have to worry about investing in expensive hardware upfront or managing a complex infrastructure yourself. It's like having access to a supercomputer on demand.
Exactly. And on top of that, cloud platforms offer all these managed services that make your life a whole lot easier. Things like automatic software updates, security patching, load balancing, they take care of all that for you.
So you can focus on the LLM itself and your application, not the underlying infrastructure. Sounds pretty convenient. Are there any specific cloud services that are specifically designed for LLM deployment?
Oh, yeah, definitely. AWS has SageMaker, which is their comprehensive machine learning platform. It simplifies model training, deployment, and management.
Okay.
GCP has Vertex AI, another powerful platform. It comes with pre-trained models, AutoML features, and tools for MOX. And then Azure offers Azure Machine Learning, which is, you guessed it, their cloud-based service for building, training, and deploying machine learning models.
Lots of options there. But what about people who are really concerned about data privacy and control? Those who might not be comfortable putting their LLM and their data in the hands of a third-party cloud provider.
That's a valid concern. And for those folks, on-premise deployment might be the better choice.
On-premise meaning you keep everything within your own infrastructure. So you have total control over your data, your hardware, and your security protocols.
Exactly. It's like building your own private fortress for your LLM, where you set all the rules and control who has access to what.
Sounds pretty secure, but I imagine there are some trade-offs with going on-premise.
There are, for sure. The biggest one is the increased responsibility. You're now in charge of everything. Setting up servers, configuring networks, managing security updates, ensuring data backups. It's a lot to handle.
So it's a trade-off between control and convenience. Cloud platforms give you that ease of use and scalability, while on-premise deployments give you that enhanced security and control, but at the cost of, increased complexity and responsibility, right?
You nailed it. Choosing the right deployment platform is a balancing act. There's no one-size-fits-all answer. It all comes down to your specific needs, priorities, and resources.
Got it. Okay, so we've covered the cloud and on-premise deployments, but what about this edge deployment that we keep hearing about?
Ah, yes, edge deployment. That's all about bringing the power of LLMs directly to the user's device, whether it's a smartphone, a smart speaker, or even an IoT sensor.
But how do you fit these massive models, these things that often require gigabytes of memory, onto devices with such limited resources?
Well, that's where those optimization techniques we talked about earlier really come into play. Quantization, model compression, knowledge distillation, they all help us shrink those massive models down to a more manageable size without sacrificing too much accuracy.
So it's kind of like taking a high-resolution image and compressing it to a smaller file size. It's still recognizable, but it takes up a lot less space.
Exactly.
And I imagine there are also advancements in hardware that are making edge deployment more feasible, right? Like more powerful mobile processors and dedicated AI chips.
Absolutely. The hardware is definitely catching up, which is making edge deployment more and more realistic.
So what are the key advantages of running LLMs on the edge, besides just, the coolness factor?
Well, one big advantage is reduced latency. When the LLM is running directly on your device, there's no need to send data back and forth to a server.
Right, so the responses are almost instantaneous.
Exactly.
That's got to be crucial for things like voice assistants and AR experiences where even a slight delay can really disrupt the flow.
Absolutely. And then there's the privacy angle. When you process data locally, it never leaves the device. So that's a huge plus for applications that handle sensitive information like healthcare or finance.
So it's like having your own personal AI assistant who is sworn to secrecy, processing all your data right there on your device under your control.
Precisely. And let's not forget about offline capabilities. Imagine a world where your smartphone can provide real-time language translation even when you don't have an internet connection.
That would be game-changing, especially when you're traveling.
Definitely.
So edge deployment offers a compelling mix of speed, privacy, and offline capabilities. But I'm sure there are also some challenges to deploying in these resource-constrained environments.
Of course, managing those limited resources is a major challenge. We need to be really smart about how we optimize those models, carefully balancing model size, accuracy, and performance. And security is paramount. We need to make sure that those LLMs and the data they're processing are protected from unauthorized access and malicious attacks.
Right, so it's not just about shrinking the model down, it's also about creating a secure and reliable environment for it to run in.
Exactly. And then there's the issue of updating those deployed models. Unlike cloud deployments where you can push out updates to all servers simultaneously, managing updates on a vast network of edge devices can be a logistical nightmare.
Yeah, I can imagine. It's like trying to update the software on thousands of individual smartphones, each with its own unique configuration and connectivity.
Yeah, it's a challenge. So while edge deployment is super promising, it definitely comes with its own set of complexities and considerations.
Right, well, we've covered a lot of ground here in terms of the different deployment platforms, from the scalability of the cloud to the privacy and speed of the edge. But there's one more crucial aspect we haven't touched on yet: the human element.
You're absolutely right. Deploying LLMs isn't just about servers and software, it's also about people. We need to consider the users who will be interacting with these systems and the potential impact on their lives.
Okay, let's bring in the human element. What are some of the key considerations when it comes to designing and deploying LLMs with users in mind?
Well, first and foremost, usability. We need to make these systems easy to understand and interact with, regardless of the user's technical expertise.
Right, we don't want to create these super complex, intimidating systems that only a select few can use.
Exactly. And along with usability, we need to think about accessibility. We want to make sure that these systems are inclusive and usable by people with diverse abilities, including those with visual, auditory, or cognitive impairments.
So it's about designing systems that work well for everyone, regardless of their abilities or technical background.
Precisely. And finally, we can't forget about accountability. If something goes wrong, if the LLM makes a mistake or acts in a way that's harmful, there needs to be a clear process for identifying the problem, addressing it, and preventing it from happening again.
So it's about taking responsibility for the systems we create and making sure they're used ethically and responsibly.
Exactly. Deploying LLMs responsibly requires us to think beyond just the technical aspects and consider the human impact. We need to design these systems with empathy, fairness, and a genuine commitment to doing the right thing.
Well said. Well, we've certainly covered a lot of ground in this first part of our deep dive, from serving frameworks to parallel processing, quantization, and even the importance of considering the human element. It's clear that deploying LLMs is a complex but incredibly fascinating undertaking.
Absolutely. And we've really only just scratched the surface. In our next segment, we're going to delve deeper into the specifics of deploying on different platforms, exploring the unique challenges and opportunities that each one presents. So stay tuned for that. Welcome back to our deep dive into LLM deployment. Last time, we laid the groundwork, talking about serving frameworks, monitoring, logging, all that good stuff.
Right, the foundation.
Exactly. Now let's get into the specifics of actually deploying these things. And a good place to start is the cloud.
Yeah, the cloud, it's become the default for so many applications these days. What makes it so appealing for deploying LLMs?
Well, a big part of it is scalability. Cloud providers like AWS, GCP, Azure, they've got these massive data centers designed to handle huge swings in demand. So if you suddenly need a ton more computing power, you can just spin up additional resources on the fly.
So no need to invest in a bunch of expensive hardware up front or manage that complex infrastructure yourself.
Exactly. And beyond that, cloud platforms offer a whole suite of managed services that can really streamline the deployment process. Automatic software updates, security patching, load balancing, all that stuff is often handled for you.
So you can focus on the LLM and your application, not the nuts and bolts of the infrastructure.
Right.
Sounds pretty convenient. But are there any situations where the cloud might not be the best fit?
Sure, there are always trade-offs. For organizations that have really strict data privacy or security requirements, deploying on the cloud might not be ideal. They might prefer to keep everything in-house, under their direct control.
Which brings us to on-premise deployment.
Exactly. That's where you keep everything within your own infrastructure.
So you have complete control over your data, your hardware, your security protocols, the whole shebang.
Precisely. It's like having your own private data center tailored specifically to your needs and your security requirements.
Sounds like the ultimate in data security and control. But I'm sure there's a flip side to that coin.
There is. The big one is the increased responsibility. You're now responsible for absolutely everything. Setting up the servers, configuring the networks, managing security updates, making sure your data is backed up. It's a lot to handle.
So it's a trade-off between control and convenience. Cloud platforms offer ease of use and scalability, while on-premise gives you that enhanced security and control, but it comes with the complexity and responsibility of managing everything yourself.
Exactly. It's a classic balancing act, and there's no right answer. It depends on your specific needs, priorities, and resources.
Okay, so we've got the cloud with its scalability and convenience and on-premise with its security and control. But what about that futuristic edge deployment we talked about earlier?
Ah, yes, edge deployment. That's all about pushing boundaries of where we can run these LLMs, bringing them closer to the user or the data source. Imagine LLMs running on your smartphone, enabling all sorts of intelligent applications that don't rely on constant internet connectivity.
That's pretty mind-blowing. But how do you fit these massive models, these things that often need gigabytes of memory, onto devices with such limited resources?
Well, that's where those optimization techniques we discussed earlier come in. Quantization, model compression, knowledge distillation, they all play a crucial role in shrinking those models down to a manageable size without losing too much accuracy.
So it's like compressing a high-resolution image to make it smaller, but it's still recognizable.
Exactly. And we're also seeing a lot of advancements in hardware, more powerful mobile processors, even specialized AI accelerators being integrated into devices.
So the hardware is catching up, making edge deployment more and more feasible. What are some of the key advantages of running LLMs on the edge, besides, the coolness factor of having an AI on your phone?
Well, latency is a big one. When an LLM is running directly on your device, there's no need to send data back and forth to a server, so you get those near instantaneous responses. That's critical for applications like voice assistants, augmented reality, anything that needs real-time interaction.
Right, you don't want to be waiting around for your voice assistant to process your request when you're trying to have a natural conversation.
Exactly. And then there's privacy. When you process data locally, it never leaves the device, which is a big plus for applications that handle sensitive information, healthcare, finance, things like that.
So it's like having a personal AI assistant who is sworn to secrecy, processing everything right there on your device under your control.
Precisely. And let's not forget about offline capabilities. Imagine your smartphone providing real-time language translation even when you don't have an internet connection. That could be a game changer for travelers.
Yeah, no more fumbling with phrasebooks or relying on spotty Wi-Fi.
Exactly.
So edge deployment has a lot going for it: speed, privacy, offline capabilities. But I'm guessing there are some downsides too, right?
Of course, managing those limited resources is a big challenge. We have to be super clever with our optimization techniques, finding that balance between model size, accuracy, and performance. And security is absolutely paramount, especially when you're dealing with sensitive data on personal devices.
Right, you don't want your AI assistant leaking your personal information.
Exactly. And then there's the challenge of updating those deployed models. Unlike cloud deployments where you can push updates out to all the servers simultaneously, managing updates on a vast network of edge devices can be a real headache.
It's like trying to herd cats, getting them all to update at the same time.
Pretty much. So while edge deployment is super exciting, it definitely comes with its own set of challenges.
Okay, so we've covered a lot of ground here, talking about the cloud, on-premise, and edge deployment. But something that struck me in our research is that it's not just about the technology. There's a human element to all of this that we can't ignore.
Absolutely. Deploying LLMs isn't just about servers and software, it's about people. We have to think about the users who are going to be interacting with these systems and the potential impact on their lives.
Right, so let's talk about that human element. What are some of the key considerations when we're designing and deploying these systems?
Well, usability is huge. We have to make these systems easy to understand and interact with, regardless of the user's technical skills. We don't want to create these super complex, intimidating systems that only a select few can use.
We want everyone to be able to benefit from these powerful tools.
Exactly. And along with usability, we need to think about accessibility. We need to make sure that these systems are inclusive and usable by people with diverse abilities, including those with visual, auditory, or cognitive impairments.
So it's about designing systems that work well for everyone, regardless of their background or abilities.
Precisely. And then we can't forget about accountability. If something goes wrong, if an LLM makes a mistake or acts in a way that's harmful, there needs to be a clear process for identifying the problem, fixing it, and preventing it from happening again.
So it's about taking responsibility for the systems we create and making sure they're used ethically and responsibly.
Exactly. Deploying LLMs responsibly means thinking beyond the technical stuff and considering the human impact. We need to approach this with empathy, fairness, and a commitment to doing what's right.
Well said. Well, we've covered a lot of ground here talking about the different deployment platforms and the importance of the human element.
It's a lot to consider.
It is, but I think it's clear that deploying LLMs is not just a technical challenge, it's also a human one.
Absolutely, and that's what makes it so fascinating.
Definitely. But before we get too philosophical, let's move on to the final part of our deep dive. We'll try to distill all this information into some practical tips and strategies for actually navigating the complexities of LLM deployment. Welcome back for the final part of our LLM deployment deep dive. We've talked about the infrastructure, the platforms, the ethical considerations. But now let's get practical. Let's say you're tasked with actually deploying an LLM tomorrow. What are the key things you need to remember? What are the strategies you need to keep in mind?
Okay, so the very first thing, even before you write a single line of code, is to define your goals. What are you trying to achieve with this LLM?
Right.
What are the specific tasks it's going to perform? What kind of performance do you need in terms of latency, throughput, and accuracy?
So it's not just about deploying an LLM, it's about deploying the right LLM for the right job.
Exactly. It's like planning a construction project. You wouldn't just start building without blueprints, would you?
Definitely not.
You need a clear vision of what you're trying to build.
Right.
And once you have that, you can start evaluating different LLMs and platforms. And you need a massive multilingual model, or will a smaller, more specialized one do the trick?
Right.
Is the cloud the right environment for your needs, or are you better off with an on-premise setup?
So it's about finding the right tool for the job.
Exactly.
What other factors should we consider during that evaluation process?
Well, performance is obviously a big one. You want to look at how quickly the framework can handle requests, how efficiently it uses the hardware, things like that.
Right.
Support for different hardware platforms is important too. Some frameworks are better optimized for GPUs, others for TPUs, and so on.
Gotcha.
And then I always say don't underestimate the value of community support and good documentation.
Yeah, that's true for pretty much any software.
Absolutely. A strong community can be a lifesaver when you run into problems.
Uh,
And good documentation can make all the difference in getting up to speed quickly and troubleshooting issues effectively.
okay, so we've done our research, chosen our LLM, our platform, our framework. What's next?
Testing, testing, testing. Don't just assume everything will work perfectly right out of the gate. Test your LLM thoroughly. Use realistic data, simulate real usage patterns, and see how it performs.
Like a stress test.
Exactly.
Make sure it can handle the real world.
And while you're testing, monitor everything closely. Keep an eye on those performance metrics. Latency, throughput, error rates. Be ready to make adjustments based on what you see.
So what are some specific things we should be watching for during those tests?
Well, latency is key. That's the time it takes for the LLM to respond to a request. You want to make sure that's within acceptable limits. Then there's throughput, which is how many requests the LLM can handle per second.
Right.
And of course, you want to keep an eye out for any errors or exceptions that pop up. Those can be early warning signs of potential problems.
So monitoring is essential for identifying any bottlenecks and making sure things are running smoothly. What other best practices should we follow during this deployment process?
Documentation. Don't skimp on the documentation. Document everything. Your code, your deployment procedures, your configuration settings, everything. Trust me, it'll save you a lot of headaches down the road.
It's like creating a manual for your LLM.
Exactly. It makes it so much easier to understand, maintain, and troubleshoot.
Right.
And remember, deploying an LLM is not a one-time thing. It's an ongoing process. You need to plan for updates, security patches, continuous monitoring. You got to make sure the system stays healthy, secure, and performs well over time.
It's like tending a garden.
Exactly.
You have to keep nurturing it.
Yeah, if you want it to thrive.
Okay, so we talked about the technical side of things, the practical considerations, and we've even touched on the ethical implications. But before we wrap up, I'm curious to hear your thoughts on the bigger picture. Where do you see this whole LLM deployment space heading in the future?
Ooh, that's a great question. I think we're just scratching the surface of what's possible with LLMs. We're going to see even more powerful models, more specialized models, new platforms, and tools specifically designed for deploying these things.
So even more sophisticated models and more streamlined ways to deploy them. What about those edge deployments we talked about? Do you think we'll all have LLMs running on our smartphones someday?
I think it's definitely within the realm of possibility. As the hardware gets better and we get even smarter about optimization, I can absolutely see LLMs being integrated into our everyday devices.
That's exciting.
It is. Imagine a world where your smartphone can translate languages in real time, generate creative content that's personalized to your interests, act as an intelligent assistant that anticipates your needs. The possibilities are endless.
It sounds amazing, but it also raises some questions. As these powerful models become more widespread, how do we make sure they're being used responsibly and ethically?
That's the million-dollar question, isn't it? And it's one that we need to be talking about right now. We need clear guidelines, robust safety mechanisms, and a shared understanding of the potential impact of this technology. It's a conversation that needs to involve everyone: researchers, developers, policymakers, and the public.
It's a responsibility that goes way beyond the technical aspects.
Absolutely.
Well, on that note, I think it's time to wrap up our deep dive. Any final thoughts for our listeners?
Well, LLM deployment is complex, it's challenging, but it's also incredibly exciting. And the possibilities are truly limitless. I'd encourage everyone to stay curious, learn as much as you can, and maybe even experiment with deploying some LLMs yourself. Who knows? You might just create the next big thing that changes the world.
That's a great message to end on. Thanks for taking us on this deep dive.
My pleasure.
And to all our listeners, thanks for joining us. Until next time, keep on exploring and stay curious.